Integration, substitution method. Integral f of g of x times g prime of x dx. Let u be equal to g of x, du is equal to g prime of x dx. Integrate f of u du, and you get capital F of u. Capital F is the antiderivative of small f. Capital F of u plus c. Put u back in, capital F of g of x plus c. Here are the guidelines. Step 1, substitute u equals g of x, du is equal to g prime of x dx. Step 2, transform integral f of g of x times g prime of x dx into integral f of u du. Now everything involves u. Step 3, integrate simpler function f of u with respect to u. Step 4, substitute u equals g of x and obtain result in terms of x. In fact, the substitution method is just the reverse of the chain rule. d dx of f of g of x is equal to f prime of g of x times g prime of x. Let's do an example. Example 1. Integral 1 over 2x plus 1. Let u be equal to 2x plus 1. du is equal to 2 dx. Algebraically solve for dx. dx is equal to du over 2 by dividing by 2 both sides. Integral 1 over u, because 2x plus 1 is just u, dx, that's du over 2, and pull out the 1/2, integrate 1 over u du. That's 1/2 ln of u plus c. Now put u back in, you get 1/2 log of 2x plus 1 plus c. Example 2. Here we have integral x e to the x squared dx. We will let u be equal to x squared. du is equal to 2x dx. Notice the relationship here, that x is half the derivative of x squared. Now we get integral x e to the u, and we need dx, so let's solve for dx. dx is equal to du divided by 2x. dx is du divided by 2x. The x's cancel out, and we get 1/2 integral e to the u du. That's 1/2. Antiderivative of e to the u is just itself, e to the u. Now put u back in, we get 1/2 e to the x squared plus c. This is the answer. Now let's do a harder example. Integral x third root of 5 minus 4x squared dx. We will let u be equal to the inside function, that's u equals 5 minus 4x squared. Notice that its derivative is a constant multiple of this term x. Let u be equal to 5 minus 4x squared. du, take the derivative. Derivative of 5 is 0. We get minus 8x dx. Integral x third root of u, because 5 minus 4x squared, that's u, and let's algebraically solve for dx. That's equal to du divided by negative 8x. So that's du divided by minus 8x. Now cancel out the x's. Let's pull out the negative 1 over 8. Integral, let's write this as to a fractional power, u to the 1/3 du. Now apply the reverse of the power rule, negative 1 over 8, u to the 1/3 plus 1, that's 4/3, divided by 4/3, that's the same as multiplying by 3 over 4. Let's simplify this, negative 3 over 32 times u to the 4/3. But the original question was in terms of x, so we must get the answer in terms of x. So we get minus 3 over 32 times 5 minus 4x squared to the power of 4/3 plus c. This is the answer. If you were to differentiate this answer, you would get the integrand back. That might be a good exercise you may want to do. All right, let's do another question. Here we have integral x sine of x squared dx. Okay, so we let u be equal to x squared. Du is equal to 2x dx. Notice the relationship that x is half the derivative of x squared. Now let's rewrite this integral. X sine of u, algebraically solve for dx. Dx is equal to du over 2x. Du over 2x. At this stage, you can't have any x's here. It has to be all in terms of u. So let's cancel the x's. Pull out the constant, 1/2 integral sine u du. And we get 1/2 integral sine is negative cos. I'll put a minus here. Cosine of u. Put u back in. Negative 1/2 cosine of x squared plus c. This is the answer. Alright, let's do a more difficult question. Integral t over third root of 1 minus 3t squared dt. We will let u be the inside function. Let u equals 1 minus 3t squared. Notice that its derivative is a constant multiple of t. U equals 1 minus 3t squared. Take the derivative, du is equal to minus 6t dt. Integral t divided by third root of u multiplied by dt. Let's solve for dt. That's equal to du divided by minus 60. dt is du divided by minus 60. Cancel the t with negative 1 over 6. Integral, write this as a exponent, u to the negative 1/3 du. Now apply the reverse of the power rule, negative 1 over 6, u to the negative 1/3 plus 1, and that's going to be 2/3. Divide by 2/3, that's the same as multiplying by 3/2. Now let's simplify this. You get minus 3 over 12, u to the 2/3. That's just negative 1/4, u to the 2/3. Put u back in, negative 1/4 times u, which is 1 minus 3t squared to the power of 2/3 plus c. This is the answer. End of lecture. In the previous lecture, I forgot to add a c at this stage, so let me add this here, plus c. That was for example 2. For this example, also we have to add a c here. And for example 4, integral x sine of x squared dx, we should add a constant of integration here. And for example 5, integral t divided by third root of 1 minus 3t squared, we should add a constant c. Alright,